vacuum at B, P ATM minus P ATM minus P, and from this absolute pressure line, this value is P ATM minus this is the P ATM and minus this P absolute at B. Note down this one. The absolute pressure. What is absolute pressure? This is gauge pressure. Suppose this one is gauge, P gauge. This is the P ATM, P atmospheric pressure and gauge pressure. This is the pressure of A, absolute pressure of A, and vacuum pressure of B. This is the less than, vacuum pressure means less than atmospheric pressure. This is the atmospheric pressure less than vacuum. This total height is P ATM, atmospheric pressure, minus this one is the absolute pressure. Understand? Now Pascal's law. What is Pascal law? Pressure at a point in a fluid, pressure at a point in a fluid at rest is same in all directions. Now proof of Pascal's law. Now before, suppose this is the container and it's filled with liquids at A points. This is the at A points. In all this is pressure always acts normal to the plane. This is the normal stress. So this is compressive, and all direction the pressure is same at point A. Understand? And another point B, suppose same pressure is same in all direction. Understand? This is pressure. Now proof of Pascal's law. Suppose a triangle element, consider a triangle elements whose this is the horizon, this is the length horizontal, this length is dy and hypotenuse length is, or slant length is ds, and this length make angle with vertical plane is theta, and pressure now y direction is py, and pressure at x direction is px, and pressure as a normal to the slant is suppose ps. So here will acting a pressure force due to the pressure is, and you consider assume thickness of the element is thickness of the element equal is 1 or unity. Understand? So the pressure is this dy Fy equal to the area, force into area, dy into y, thickness 1. Understand? This pressure force due to the pressure acting on the element is in y in x direction. This here another pressure force Fy, oh sorry, this one Fx and this Fy, and this pressure force due to the pressure acting on the element in y direction, and the area, pressure into area, is dx into 1. This is the thickness, and the slant force equal to Fs equal to pressure into ds into 1, and the weight of the elements, weight on the elements is the now weight of the element equal to the weight of the element, first weight density rho into g into volume, area is, this is the triangular element, so half into dx into dy into thickness is 1, so rho g dx dy by 2. This one is rho g dx dy by 2. This is the weight. Now fluid at rest, fluid is at as fluid is at rest, so summation of F equal to 0, and this Fs is resolved in x and y direction. Previous lecture I how to measure angle at this. Suppose this angle vertical and inclined plane. Suppose this is the vertical and this angle is vertical plus incline, theta, suppose. Now consider suppose this is the consider Fs. Suppose there is now inclined plane resolve into, this is the dy, this is the Fs, and suppose the vertical and inclined plane. This angle is theta. So vertical, and this is suppose incline, another plane incline parallel, and this angle is theta. This, so total angle is 90 degrees, so 90 degree minus theta. Understand? So this theta, this and these two angle is 90 degree. This also obviously 90 minus this angle, this is total 90, so this angle is 90 minus 90 degree plus theta, so theta. Understand? So this one is theta. Understand? So this is the fs cos theta, this one is the fs sin theta. Understand? So summation of f. Now summation of x, we consider positive x direction is this positive and this one is negative. Consider, so x direct positive x direction px into dy, and another fs mean ps into ds into cos theta equal to 0. So from there cos theta equal to base is dy by hypotenuse is ds, so and dy equal to ds cos theta. Understand? So px into dy minus ps suppose this one is ps into dy, so px equal to ps. Same summation of fy equal to 0. This one is positive y direction py into dx minus this was downward ps into ds into sin theta, ds into sin theta, and minus rho g ds dy by 2 equal to 0. This is very small elements, so neglect, very small, so neglect this one is 0, neglect. So py into dx minus ps, another sin theta equal to perpendicular dx into ds hypotenuse, other dx equal to ds sin theta, so ds sin theta equal to dx equal to 0. So py equal to ps or p, suppose ps equal to p, so ps py equal to p. Proof Pascal law for 3D. For 3D system, Z also consider px, py, pz equal to p. This is the proof of Pascal law. Pressure at a point in a fluid at rest is same in all direction. Next is law of transmissibility of pressure. Transmissibility of pressure. Law of transmissibility of pressure. It states that pressure change at any point change at any point in a confined incompressible liquid. Incompressible liquid, and this is pressure change at any point in a confined fluid is transmitted throughout the fluid such that same change occur everywhere. Suppose this is the this is the external pressure is applied on the fluid. There is a PA pressure. This is the PV pressure. Now absolute PA pressure is the P fluid at A plus P, and PB equal to P fluid. Both are external, P is same, and the application of the law of transmissibility of pressure. Hydraulic jack. Hydraulic jack. Suppose this is the This is the small pistons with area, small pistons with area A1 in a cylinder to lift large piston with area A2. And here F1 is, this is the F2, and here pressure is always normal to the plane. This is container, from the Pascal law P1 equal to P2, so F1 by A1 equal to F2 into A2, so A2 greater than A1, so F2 by F1 equal to A2 by A1, this one greater than, so F2 greater than F1. Proof. So you can say low force is applied it's not to lift more weight. Understand my points? Same here, pressure is same, here pressure same. Small pressure, here force is low force, you can lift more weights. Same case you can say JCB machine.